Hello, it's Hank, and I'm here with Madelyn Leembruggen, who is our new SciShow Resident. This is a project that we do where we invite interesting and exciting science communicators to come and work with SciShow for a little while. They write scripts, they host scripts, they pitch scripts, they pitch them first. It'd be weird if they did that last. Madelyn is a PhD physicist, studying the PhD of squishy things. Is that what you told me?
Yeah, squishy physics.
Squishy physics.
The official name is soft matter physics.
That seems important and hard.
Yes, the soft stuff is hard.
And the hard stuff is easy.
Yes,
nice.
Because the hard stuff doesn't move around as much.
It just, it does exactly what you would expect.
Yeah, the other thing that makes squishy stuff hard is that it's at normal temperatures. For most of physics, you either look at really, really high temperatures or really, really low temperatures. So squishy physics is like the physics of every day, which is complicated.
It happens at normal temperatures, but also squishy, I feel like it could change not on a pretty low temperature range. Judging from my mattress, it can be quite hard if it's cold, and it can be quite soft if it's warm.
Your mattress has that much temperature dependence?
Right when I get in, I feel like it's a little harder.
Interesting.
Maybe I'm not a PhD physicist.
but yeah, there's a lot of changes that can happen in a material based on its temperature. So you have to have tools that work over a really wide range of temperatures and conditions in order to study these non-equilibrium systems.
What's a non-equilibrium system?
That is one that is changing and moving all the time. Sure. So usually we talk about equilibrium means that it just sits there and it will be that way for all of eternity.
Right, even if it's moving, it's...
Yes, it's not the bulk properties of it, the things that we measure like temperature and pressure, those aren't changing. So non-equilibrium is if you push something that is squishy the whole time, that is moving. And so that's a non-equilibrium process.
What was your thesis about?
It was about crumpling paper.
Oh my God. Is paper squishy?
So this is where soft matter is kind of a catch-all.
Sure.
Squishy physics is the fun name, but not everything is quite squishy.
Sure. Well, I mean, look. A piece of paper in a stack is hard.
Yes.
But a piece of paper crumpled up is squishy.
It's squishy. Yeah. So that's the connection there. Gotcha. But yeah, I made computer simulations of very thin sheets and watched them as they get crumpled into balls. There's actually some really interesting statistics in the pattern that you get when you crumple something. Interesting.
This is what we learn. Is well, why would we do that? And then it's it turns out that it's going to make AI smarter or something.
Or something.
It's just you're going to be able to predict the future better because we crumpled up thin sheets of paper instead of computers.
Well, one of the applications is potentially in batteries because having a lot of surface area in a relatively small amount of volume can help increase battery capacity. And then there are questions like memory. A lot of these advancements in AI came out of statistical physics, which is one of the main tools we use in soft matter physics. And what they look at is these systems that have a lot of seeming chaos, but there are patterns in them, and there are ways to traverse those patterns and store information in them.
Well, what we did, because we knew you were going to be here, is we asked on the community tab on YouTube if people had questions about physics. Questions that I certainly could not answer. I mean, maybe I'll know some of these things. But do you want to answer some questions from the SciShow audience?
I would love nothing more.
Great. Let's establish your credibility. Okay, we got a question from KC who says, wait, there are over a dozen states of matter? What's the difference between a state and a phase of matter? Are those terms interchangeable? Is there a subtle difference? Boy, 1, I didn't know that there were 12. I don't feel like there are. 2, but you're going to tell me.
I'm going to tell you.
2, I had never noticed that state and phase were both kind of used in this discussion.
I would say that states are within the basket of phases, but phases are a much bigger basket.
Ooh.
So
right.
I would say that there aren't dozens of states of matter, but there are dozens of phases that various systems can be in.
You're going to have to explain that now.
Okay, so states of matter.
Can I tell you the states I know about?
Yeah, tell me
There's
those.
Solid, there's liquid, there's gas, and there's plasma.
Yes.
Those are the ones.
Yeah, those are the main 4 ones. Those are what I would call states.
Okay.
There's a half of one.
The Bose-Einstein condensates?
Yes.
All right.
I only count that as a half because it would be really hard to make that out of most things.
Yeah.
But like plenty of other things can be those other 4.
Okay.
So those are like the 4.5 states of matter.
I like that you've demoted Bose-Einstein condensates just on vibes.
Listen, I have big love for them, but they're very impractical.
Sure.
Like most
They're
people
not
are
around.
never going to come around them.
Yeah.
So maybe we'll talk about it later, but there are some interesting dark matter candidates that could be, that could form Bose-Einstein
Yeah, like is a
condensates.
neutron star a different state of matter? Just a bunch of neutrons? That seems like a different thing.
It's that get. I don't.
I say it is.
I would call it a phase.
Okay, so we can get
yeah.
into phases now.
So I wouldn't call that a state of matter because by the time you get down to a neutron star, this is just like a goo of neutrons.
Yeah.
Those aren't atoms or molecules anymore. They don't. It's just neutrons. It's not like water in the degenerate neutron state.
Right. You couldn't like get water into a neutron star. It's not water anymore.
Yeah, it's not water anymore. It's just neutrons.
Yeah.
So that starts to be a kind of phase. And so then a phase is a collection of atoms that all share a set of properties.
Or particles.
Or particles.
Yeah.
Yes. They don't even have to be atoms or molecules. They could just be particles.
Yeah. Like just a spoonful of electrons. That would be bad.
I don't think it would taste very good.
No, I think you would. I think you would blow up your whole neighborhood. Yeah. What are some other phases besides just a pile of neutrons?
The phases depends on what you're talking about. One of my favorite examples of phases is liquid crystal displays.
Okay.
So I know that we don't use those very much anymore.
They're still around.
They're still around, though. Yeah. So the liquid crystals in there are these little particles that line up in certain ways depending on how you apply an electric or magnetic field. Mm-hmm. And the way that they line up with each other is what allows different kinds of light to come through and make the picture on your screen. So they can have different phases. They can have a phase where they're all lined up like this. They can be like all kind of lined up, but in different levels. The one that's in your computer is they make these little like twisty. Yeah. They make a spiral, so they stack on top of each other like a helix, and then that like charters the light around.
That's a lot more complicated than like the calculator one. That's just sort of like gray on gray.
Right, right. So, but the like tricolor ones that if it's changing the pixel from red, green, blue, then the exact shape of the helix will control that.
I just learned so much. I can't believe I did not know that there was a difference between phases and states.
Yeah.
And this makes sense.
In my PhD research, I worked on, one of my projects was on ribbons, twisted ribbons. Mm-hmm. And the ribbons that I studied had 7 different phases, ways that they deform when you
is that
give them
like
a twist.
Similar with ice where there's like a bunch of different potential crystal structures of ice? Like there's ice 12 or whatever?
Yeah, I would say that's really similar in that ice has, I think it's up to 20 now.
Yeah.
It has different phases, but those are all still solid state of matter, but there are different ways for the crystal to form, and I would maybe say that those are different phases.
Okay. That's a pretty broad category then.
Yeah.
It's weird. You can have like super hot ice, it turns out, if there's enough pressure.
Yeah. I was reading about that recently.
Hot ice.
Yeah.
SciShow topic. Let's do this one from Ghost Pancake. What actually is plasma? I've heard about 50 different explanations for what it is, but I still don't understand that to this day. Well, this day is the day your ignorance ends. What is plasma?
So plasma is like a big soup of atoms. There are some neutral atoms, but then there's so much energy that some of the atoms get partially ionized. They get their electrons stripped off.
And they're just like, the electrons are just jumping around.
Exactly.
Yeah.
So you have these positive ions. You have the negative. Yeah. You have the negative electrons. And then you do still have some neutral atoms. And because you have all of these charged particles in this big energetic soup, then it means that it's really good at conducting electricity.
Gotcha.
So one of the distinctions between a plasma and a gas is how well it conducts electricity.
And the confusion that I have had about plasma is like, well, if it's just a soup, then how does it still have hydrogen and helium and carbon and oxygen in it? And the answer to that question is those things are defined by their nuclei, not by their electrons.
Exactly. Yeah. Yes. And it's only a partially ionized gas. So there's also a way to have, if you go all the way back to, a couple hundred of thousand years after the Big Bang,
Sure.
then we had a different kind of plasma. That was the quark gluon plasma. And
That
that
sounds squishy.
it would be hard to get enough of it to
Feel it.
to squish it. Yeah.
I've always wondered what the sun would feel like if it didn't burn you. So just like take the energy out of it.
Yeah.
And just be like, let me touch it.
Well, someone asked a question really similar to that.
Oh.
They asked, or do you want to read it?
Yes, it's from Peter, who asks, what kind of vehicle would you need to travel through or across the sun, assuming you could magically ignore the heat and gravity? Oh, Peter and I are right on the same wavelength. Would it be a car, a submarine, an airplane, a surfboard? Basically, what is the consistency of the plasma of the sun?
Yeah, it's a good question. I had to look into this one. It changes a lot. So if you're talking about the core of the sun, that's actually about 150 times denser than water is.
Okay.
So
I would float.
You would be able to walk on it.
Yeah.
It'd be like oobleck or maybe even like rock.
Oh, wow.
So you would need...
You might as well be walking on the sun. Smash Mouth was right. You're allowed to laugh, Buzz. You can make noise.
No way.
So if you wanted to like drive through the core of the sun, have you seen Atlantis?
Uh-huh.
You know, the big drill?
Yeah.
That
You need
one of those.
You need a big sun drill.
Yeah, need a really big sun drill.
Okay. But right at the outside. Fluffy.
At the outside, then you're like getting, that's like upper atmosphere of Earth.
Oh, wow.
You know, you're transitioning to vacuum. So you need like a spaceship that has really good boosters for the very outer bits of the sun.
So you're just like orbiting it, theoretically.
Yeah.
And you're just sort of like going through it.
But then if you go like a little bit deep in, then there is like a layer where you could like swim laps or whatever.
Oh.
Because the density will change from like being really super dense.
So there's like a layer at every...
Yeah.
And basically there's like a point at which I would float. But it'd be in there.
Yeah, you'd be like pretty far in there.
Yeah, I couldn't like see the stars anymore.
No, probably not.
Yeah.
Yeah.
Neat. Thanks, Peter. Thanks, Madelyn. Can anything become a plasma? If it's hot enough, can there be uranium plasma? Like what? I guess. Yeah. No. Well, look. Why did I say that? I know nothing.
So maybe because uranium is so unstable to radioactive decay,
Yeah.
I think it might break up into smaller elements before you could
if there's
fully ionize
that
it.
much energy around, then it's going to be getting hit with some neutrons and stuff.
I think so.
Yeah.
Yeah. So it might not live to see enough ionization to become a plasma.
Gotcha.
But I think, in theory, you could make a plasma out of anything because it's only partially ionized. So like we were talking about.
You don't have to get every one of the electrons off. You got to get one off.
Yes. So it can maintain some of its identity.
Yeah. You could make a plasma out of all of my elements, for sure. In fact, the sun, I think, has all of them.
Yeah, that sounds about right.
Trying to think of, I've got some lead. No. What's the one? Iron. Not lead.
You've got lead in you?
Probably a little bit. I was alive in the 80s.
I've got a lot of plastic in me.
Yeah.
So.
we both got that. I got the lead and the plastic. Okay. The American asks, they wanted to be clear, why don't I have a plasma sword in the year 2025?
Asking the important questions here.
Yeah. It seems like it would be hard to do.
I think it would be.
I mean, what's the stuff inside of the tokamak fusion reactors? That's plasma, right?
That is plasma, yeah.
And they're trying to contain it.
Exactly.
And it costs billions of dollars to make a donut of it.
Yes. It takes the most powerful magnets that humans have ever been able to create to contain the plasma inside these like tiny test nuclear reactors.
Yeah, fusion reactors. Yeah.
Fusion reactors. So, to make a plasma sword, you'd have to have a really, really, really strong magnet in a pretty precise shape.
Right.
So
you got to hold it, and then you'd have to keep it exactly where it is.
Yes.
Like, I got my plasma sword, and then in order to move it, all the magnets would have to direct the plasma.
Yes. And you probably don't want your cell phone near the plasma.
No, you wouldn't want any, like, don't wear a ring either.
Yeah.
You'll rip your finger right off.
Mm-hmm. Yeah. All of the, like, MRI warning signs.
Yeah, that times 100.
Yes, exactly. So I think plasma swords would be pretty hard.
Yeah. We have really strong lasers you can buy on eBay, though. So
That's
don't
true.
do it. But they are there.
You have to listen Don't do it.
Levi Bauer asks, is sublimation really a direct phase transition between a solid to a gas, or is there like a small microscopic layer where the solid is actually a liquid that then evaporates?
I like the thought process here.
Yeah, can I tell you? Yeah. I am of the opinion, and I believe I have said this in videos before, that there is no liquid, so I hope I'm right.
You are right. Oh. Yes. So according to my StatMech final first year of grad school, sublimation and deposition are real independent processes that can happen. This is separate from melting and then evaporating. Yeah. Basically, with sublimation, you have a crystal, you have the solid, and then the molecules are peeling off directly from the solid into the air or whatever.
Yeah, and it's because like the temperature and pressure of the system, like the pressure of the system would not allow for a liquid to exist.
Exactly, yes. And
of that material.
Mm-hmm. And the opposite can happen too. The opposite is deposition, where vapors in the air just directly, instead of condensing and then freezing, they directly deposit into the crystal.
And deposition happens all the time.
Yes.
Especially in labs where they're making cool stuff.
Yes. Yeah. That's a really important way to grow crystals, or if you see like frost on your windshield in the winter, that's usually also a deposition process.
Yeah, if it's making those cool crystal patterns, for sure.
Yeah.
Which happens like every like couple of years, all the cars will be covered in like beautiful, perfect, car-sized snowflakes.
Yeah. Yeah.
So cool.
They grow in such cool ways. You can also see sublimation in your freezer if you ever notice that your ice cubes are shrinking.
Yeah.
That's sublimation. So that means that your freezer is not humid.
Too cold for there to be liquid.
Exactly.
But they are still shrinking.
Yes.
Wild. This is a related question from Joel, who asks, are the states of matter really a binary thing, or do we just use these ideas to describe a more gradual shift in the molecular structure of matter? I feel like it's a binary thing.
The answer is yes and no.
Okay, great. That's my favorite answer.
So sometimes it is binary. If you're talking about sublimation, the answer is binary. Is this part of the solid or is it part of the gas?
Yeah.
There are certain kinds of phase transitions that don't happen in this binary way. They happen more continuously. We call them continuous phase transitions.
Oh. Yeah. Which ones? In what circumstance? Can I watch?
There is, you can watch one of these. One of the demos that I really like, it is a video of liquid CO2. Uh-huh. It's in a chamber, so it's liquid and gas, CO2. Gotcha. And then it goes through a continuous phase transition to become a supercritical fluid.
Gotcha. So this is like triple point stuff.
This is
related?
Beyond this is a different part of the phase diagram.
Okay.
Basically, there's a point where the supercritical fluid, it reaches a point where the density of the gas and of the liquid are the exact same.
Oh.
And the way that we define the difference between a liquid and a gas is by how dense it is. Mm-hmm. So if that density matches, then it becomes like one big fluid thing.
Wild.
Yes.
Okay, that makes sense that would happen for most things that are liquids and gas. Like there's a point there, because liquid pretty much has a constant density. Am I wrong about that?
A given liquid has a characteristic density, yes.
Gotcha. So you'd have to like figure out a place where the gas has a density. It's still a gas, but has the density of the liquid, and then you're like...
And for most liquids that we know, that's like a really outrageous set of conditions. Yeah.
Carbon dioxide is pretty weird.
It is, yes. Yeah. Its phases are actually really similar to water, but they happen at lower temperatures and pressures generally. Yeah. Since CO2 is, normally a gas at STP. But
standard temperature and pressure.
Yeah, sorry.
Continuing on our journey to better understand phases of matter, which I thought was really simple, and I thought I understood, but I keep learning new things in this one conversation.
Spent 6 years studying it, and I'm nowhere close to done, so...
Okay. Well, Alexis asks, what is up with supercriticality? I think it's so cool, but my brain can't seem to grasp exactly what it means. It's a liquid and a gas at the same time, but those are different things. Did we just kind of talk about that?
We did a little bit.
Okay.
And I'll give another example, but this is just a weird thing. It is, I don't blame Alexis for not being able to parse this. This is a really weird thing that happens in nature, that happens in physics. So the analogy that I like to give is the difference between a gazpacho and like a chunky salad.
Oh, those are pretty different things.
But they have the same ingredients, with like similar ingredients.
Sure. You could make a chunky salad out of the ingredients of a gazpacho.
Yes. And so if you take that chunky salad and you like chop it up a little bit more finely, then like at some point you might call it like a salsa.
Yeah.
But then think about the
I would,
array
in fact. I definitely would.
So then think of like how many different types of salsa there are.
Yeah.
There are ones that are chunky.
Super chunky.
And then there are ones that like are pouring
Pretty
consistency.
soupy, yeah. And then there's eventually.
And then eventually you get all the way
Gazpacho.
back to gazpacho.
Yeah. At what point when you're buying a salsa are you like, you just sold me gazpacho?
Yes, exactly. Yeah. Like at what point do you say this has become soupy? This salsa is a soup now.
Yeah.
And so
Supercritical.
Supercritical. Salsa is a Supercritical food.
Somebody thought of that joke listening to this right now. like a half a second before me. And they were like, oh. So what does that have to do with the states of matter?
Yeah, so that is an example of a continuous phase transition where you went from having a salad to having a soup, but there was like no point in between where you could like draw a line. And the answer is that it is both. It is neither. It is its own. It is supercritical.
How do things get into supercritical states?
You have to tune them really specifically. Okay. You can alter their temperature and their pressure.
Carbon dioxide a good one?
Carbon dioxide is a really good one. If you are on YouTube right now, which I assume that you are, then
otherwise you're a pirate.
Then you can search up videos of supercritical CO2. There's some really good videos on YouTube of it, and it's like trippy to watch because it goes from having this like visual line separating the liquid from the gas to just like being one big cloud.
Wow.
Yeah.
That's cool. And then if I put my hand in there, aside from it being a really weird temperature and pressure and probably being injured, it would feel like a mix between a solid and a liquid?
Yeah, I would guess so. It would. This is really a question about density.
Yeah.
But in my head,
not just density, like also like how stuck together the molecules are.
That's true.
Yeah. Who knows?
In my head, it's like in San Francisco when the fog just like descends and you're walking through the pea soup of it all. Yeah. In my head, that's what a supercritical fluid feels like.
I mean, solids are weird. Like it's weird for solids for me because it's like solid is a solid.
Yeah.
Solid is like
it's a solid. Mm-hmm. Yeah.
So if I can like push my hand through it, it's not a solid. But is it like a foam? Foam I can push my hand through.
Don't get me started on foams. That's a whole other episode.
And that's the title. Don't get me started.
Nicole said we only had 10 minutes left and you're going to ask me about foams? Oh my gosh.
Occasionally there'll be a paper about like cappuccinos in a physics journal, and I'm like, man, you guys, you got too curious.
Physicists love foams. Let me tell you, there's a lot there.
Yeah, solid foams, aerogels.
Aerogels, those are fun. The thing about foams is that they are like gas phases incorporated into either a solid or a liquid phase.
Yeah, and then it can be a gas phase incorporated into a liquid phase, acting like a solid.
Absolutely. Yes. Yeah. Stupid. Stupid how it works.
They should be illegal.
They probably should. They're too fun.
They're too fun. That's not. I thought it was going to be too weird. They're too fun. They should be illegal.
Well,
like they're drugs.
They're fun because they're weird.
Okay. Madelyn, this was really fun.
I've had a great time.
I learned so much.
Good. I'm so glad.
Thank you for being our resident. Madelyn's been writing for SciShow for a while now. Thank you for all of the scripts you've pitched and written for SciShow, and also for coming in and hosting.
I have just had such a great time.
Over the next 10 weeks, Madelyn, you're going to be hosting a bunch of scripts that you pitched and wrote for SciShow. Mm-hmm. So she'll be here. You can come back every week and see Madelyn on SciShow channel. Thank you. 10 scripts, that's a lot of work.
It was.
I know you're also doing a bunch of other stuff at the same time.
Yes. So it was worth it. It was so much fun.
It's fun.
I'm going to keep pitching and writing even after this.
Yay.
So
Awesome.
I'll be around.
Cool. And if you support us on Patreon, this is the kind of cool stuff you're allowing us to do. Thank you so much. It's really, I think, important to be able to, in the science communication world, be making bridges and working with people and figuring out how we do this job, which keeps changing.
It do.
Cool. Well, we're going to go talk more about foam, but we're going to turn the cameras off.